Your immune system is incredibly awesome. It acts like the security guard for the new bar in town, which just happens to be your body. When your cells show ID, they're let in without a problem. When bacteria or viruses show their ID, the security guard calls his buddies and the intruders are kicked out. This is great, except for those few times where you actually want something to sneak past security. One of these times is an organ transplant. Before a patient receives their new heart, liver, kidney, or other organ, their security team is given a memo. VIP guest tonight. No ID check necessary. See picture below. This works for most patients, and the organ can stay healthy for a long time. However, even with this memo, every transplanted organ experiences something called ischemia reperfusion injury, or IRI. IRI happens when the organ is taken away from the donor's blood and stored on ice, ischemia, and then connected to the new patient's body, reperfusion. These steps damage the organ, and if the damage is severe enough, it can activate the immune system and override that memo. This puts the organ at risk for rejection, the equivalent of getting kicked out of the bar. Currently, there is no way to predict or prevent severe IRI. Last year alone, 37,000 organs were transplanted in the US, and all of them were at risk for this problem. But what if we could prevent severe IRI? As someone interested in immunology and improving patient lives, my research aims to answer two questions. What is the difference between patients who do and do not have severe IRI? And how can we use that difference to prevent severe IRI and guarantee that the new organ will be and stay healthy? To answer the first question, I performed a set of experiments to find out exactly how IRI affects immune cells. I took normal, healthy immune cells and put them into blood collected during liver transplant surgeries done at UCLA. After a week, I analyzed the molecules on the cells. I found that blood from patients without severe IRI made cells express molecules that send the all-clear signal. This suppresses the immune system, like an officer de-escalating a situation. On the other hand, blood from patients with severe IRI made cells express molecules that sent the code red signal. This activates the immune system, like the SWAT team calling for backup. This molecular difference is exactly what I was looking for. With knowledge of this difference, the second part of my research will focus on what types of treatments can guarantee that transplant patient immune cells will only show the all-clear signal. Ultimately, these treatments can help eliminate severe IRI and therefore increase the health, longevity, and quality of life for transplant patients across the US and around the world. Thank you.